Hey everyone, Sean here for Lambda School, and in this video we're going to be talking about networking protocols as part of the web server sprint. The objective here is to learn about networking protocols, what they are, and what they're for. So first off, what exactly is a protocol? Well, a protocol in simple terms is pretty much just a contract between two parties. And in the case of networking protocols, here we're basically talking about a contract between the client and the server, kind of stipulating how if the client sends data of some form to the server will send back data of a certain specified form. So if the client sends the server X, then, and if assuming X is of the correct format, the server will go ahead and send the client back Y, some response of a given format. That's essentially what a protocol is. So now let's talk a little bit about how this is actually implemented, how protocols are basically implemented when it comes to sending out packets of data. And this is basically done through data encapsulation. And what that means is that, let's say we have the data we want to send at the very bottom segment of this table, just a hello world in an H1. Basically, this piece of data is going to get wrapped in different headers, right? So oftentimes we've seen, if we open up the network tab in a browser, you'll be able to inspect things such as an HTTP header. And the HTTP header in this case is just one protocol. HTTP is just one protocol that's part of the networking stack that is utilized in order to send that packet from one place or one client, from a client to a server. So HTTP is just one protocol that's used along the networking stack, and so it has its associated header. And then next up on the networking stack, you might have a protocol like TCP. So, and since that's next in the networking stack, that will then be the next layer that will encapsulate this data packet. After that, you have IP, which is the internet protocol, and after that, the Ethernet header. And so each of these headers deals with different parts of the networking stack, right? So you can imagine then as you are sending a piece of data out from your machine out into the open internet, again, the first thing it'll get encapsulated by is HTTP, because at that point you might be making, let's say, like a GET or POST request with that data. So first it'll get wrapped with HTTP, with the HTTP header. After that, then next is TCP. Assuming you're using TCP, you might be using a different protocol. We'll talk about a little more of that later. So TCP might be the next header that will encapsulate this data packet, this growing data packet as it's getting sent through the network stack of your machine. And then IP, and then finally Ethernet, Ethernet deals with your local routing on your local area network. Right, so that's taking that encapsulated data packet and sending it literally over the wire, your local wire, out into the open internet. And then from there on, IP deals with routing over the open internet, so figuring out how to get that packet that was just sent out from your Ethernet out. Once it's out in the open internet, it needs to traverse a whole bunch of different nodes in the internet in order to get to the specified destination. Next up, TCP, again, deals with data integrity or reliability. And again, we'll talk a little bit more about TCP in a second. HTTP specifically deals with web data. Since we're using the internet, we're using the web in order to send this data out, we'll be using HTTP in order to do that. And then lastly, you have your actual data. So that's a little bit more about how these networking protocols are actually kind of implemented, or how they actually affect individual packets of data as they're getting sent out over the network. They increasingly just kind of encapsulate the data and wrap it in their respective headers. So now, as promised, let's talk a little bit more about TCP. Specifically, well, TCP is one that we'll talk about. So again, TCP stands for the Transmission Control Protocol. And then we're also going to talk about another protocol you might have heard of called UDP. So in the case of TCP, TCP is very commonly used, and in most of the projects that you guys have probably worked on where you are sending data out over the web, making HTTP requests over, with gets or puts or posts or anything like that, you are most likely using the TCP protocol in order to actually do that. So anyways, let's talk a little bit more about what TCP is. The whole kind of point of TCP, of the TCP protocol, is that it's considered extremely reliable. So it's best for use cases where you don't want to have any data lost, right? So if you're sending, or if a server is serving a web page to a client, TCP is most likely going to be the one that's used because you don't want any bits of data on that web page to be lost on its journey to the client, so that when the client actually goes and requests some web page from a server, all the pieces are there, right? And so TCP provides that reliability. And the way TCP provides that reliability is through kind of what's called the three-way handshake, right? So looking at this diagram here, on the left we have the initiator, typically the client, because the client is the one that's initiating communication with a listener, in this case, the server. So you might imagine that the initiator, the client, will send out, here it's called a SYN message, S-Y-N, SYN message, to the server. This is kind of the first message saying, hey, I want to connect. So once the server receives that, it'll send an acknowledgement of the SYN back to the initiator, upon which the initiator, once it receives that, will send a final acknowledgement back to the server. And the server needs to get both of these messages. It needs to receive the initial SYN, and then it needs to receive the following acknowledgement message. Because at that point, then the server can be sure that the connection between the server and the client is reliable, and no data is going to get dropped as they actually go and send data back and forth through that connection. And only after the server receives the acknowledgement can it finally go and actually send the requested data on the client's behalf. So only after the acknowledgement is received can data packets actually finally start to be exchanged over the connection. And so again, this is how the TCP protocol ensures reliability. Next up, let's talk a little bit about the UDP protocol. So if you haven't heard about the UDP protocol, UDP is, in contrast to TCP, is very much like a gushing fire hose. So in the case of UDP, UDP just splatters out a whole bunch of data packets and doesn't care at all about reliability, in the sense that it doesn't care. It sends out a much greater volume of packets over the connection, and it doesn't put forth any safeguards saying, hey, this is what's going to happen if some packet gets lost. Because one thing that TCP does do is that if it doesn't receive the final acknowledgement in the three-way handshake, then TCP will go and try to make that communication again up to like a certain cap. So it'll keep trying. If any data is lost over a TCP connection, TCP will try to go and resend that data so that the client will still eventually get it. And so at the end of the day, no data is actually still lost. UDP doesn't do that, right? So UDP, again, sends out a whole bunch of data packets, and there are certainly many applications that require this extra volume of data packets. And so those, you can think of that. So those certain applications that make use of a much greater volume of data packets, the UDP protocol can't really be expected to ensure that every single one of those packets is actually reliably received by the client, just because of the sheer volume. And so that's kind of how the TCP protocol works at a very high level, is that it cares much more about volume, and it doesn't care so much about the client actually receiving all of the packets that it sends out. So oftentimes in the case of applications that make use of the UDP protocol, you can expect a certain percentage of packets to be lost, and certainly in those applications, they kind of they normalize for that.